Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aiman Mukhtar bin Dahari, and this is my final year project, and the title is Analytical and Experimental Evaluation of a Bicycle Stunt Pad. This is my personal background. This is my name, my ID matrix of UiTM, my email, personal email, my phone number, and my supervisor is Professor Ahmad Kamil Hussein. A bicycle pad or stunt pad on a BMX bicycle is a small component that we all that all the riders connect to their bicycle to make a various stunt action and maneuver. And what is my analysis is how the strong the stunt pad is. It maybe when it will be bent or when it will be cracked. To answer my question, this project I will do a finite element analysis on three different bicycle pads, and I will use CATIA to utilize the model each pad as a cantilever beam and to analyze it. And based on flexure theory, the stress and the deflection of a beam are correlated to its length, cross-section, and material type. And that's why I will analyze on three different bicycle pads, and then on and then I will do a non-destructive test on one of the pad. I will choose one of the three pads, and I will do a physical testing on it. And on the physical test, I will use strain gauges to measure the stress and deflection measurement, and the result maybe is provide the ratio of strain and displacement. The physical test result may be expected to comparable to FEA result. This is the three selected pair has been chosen from me, and the first product is on the left. The material is aluminum alloy and doesn't have no brands. The length is 100 millimeter. The outside diameter is 25 millimeters. And inner diameter is 20 millimeter. And its price is just 6 ringgit and 50 cents. And the second product is in the middle. It made from plastic and steel. The plastic is outside and the steel is inside. And the brand is Mission Taga. The length of the product is 115 millimeter. The outside diameter is 40 millimeter and inner diameter is 20 millimeter. And the price is 88 ringgit and 90 cent. And the last product is on the right. Its material is alloy. The brand is Duty, and its length is 80 millimeters. Their outside diameter is 25 millimeter. Inner diameter is 15 millimeter, and the price is commonly pricely is 138 ringgit. This is my literature review. The number one is from the journal Torsional Behavior of Hollow High Strength Fiber Reinforced Concrete Beam. This journal they made the cross-sectional dimension had the greatest influence on the cracking moment of the test beam, while the wall thickness and the type of cross-section had the least influence. Uh, it mean they are analyzed the cross-sectional dimension, the different dimension of cross-sectional. The increase of cross-sectional dimension that will make the decrease cracking moment. And then the second literature review is from Theoretical and Computational Analysis of Circular Cantilever Tapered Beam. This journal is to determine the stress field in the design of tapered beam under different loading conditions. They design the method to take the advantage of tapered beam to effectively use for structure. They make a analysis about the tapered beam, the different tapered beam to determine the stress field. And the third literature review is from analysis of the material of existing motorbike rail sprocket with using FEA. They use 4 different material. That means AISI 10 and 40, IC 4140, AIC 20%, and AICIC 30%. This instead of chromoly steel, and they analyze the different chromoly steel to find the yield and the tensile strength and stress and deformation. And the last my literature review is from the analysis of a crankshaft made of EN8 compared to the crankshaft material from AIC 4130. This literature show that the stresses within the rotating shaft are well within the safety limit, which is the subject of my dispute. And the conclusion of this journal is EN material can support a fixed force and has a good strength, so it's not necessary to replace the IC 41 and 4130 crankshaft with it in terms of strength. My project objective is to perform FEA on 3 different bicycle pad using CATIA. And second is to perform a non-destructive static test on a BMX stunt pad. And the third one is to compare the FEA result and the physical test result with the flexure theory. And the scope and limitation of this project is only evaluate 3 different stunt pads through physical testing and FEA simulation. And for the physical testing, only one of them will be taken for testing, and there is a limited number of strain gauges because strain gauge is quite pricey to buy, and strain gauges are used in this project, and we will find the stress and strain for the result. This is my methodology. So the first one is design of the cylindrical cantilever beam base. According to this study subject, the stunt pad has a hollow cylinder-like shape. That's why the analysis employed for this project is a hollow cylindrical beam that functions as a stunt pad. And then we cantilever beam experiment. Why I use the cantilever beam experiment because the stunt pad has a fixed end and a free end like cantilever beam experiment. Then I will apply theory of hollow cylindrical cantilever beam. Next is analysis in CATIA. Analysis in CATIA, I will make a shape or product like stunt pad, and then the material that I have chosen is aluminum alloy. Why I doesn't choose a chromoly? Because I doesn't find I do not know where the chromoly feature. And then FEA simulation is done by placing the force is about 1000 Newton on the right side or the free end side. And on the left side of his end, I will put the I will put the fixed end as a support at the fixed end, so it doesn't move. It's truly like a stunt pad. And the last one is testing and analysis of the product. So from the three stunt pad that I chosen before, Mission Targa branded stunt pad I will be chosen for physical testing. The last part of my presentation is expected result. If we can see on the right side, and the top of the figure is about stress from misses from the Katia, and the below is transitional displacement. And from the analysis, I expected the result is numerical method and the physical test will be different, but the pattern is still the same when we comparing the two results. And for the next semester on FYP2, I will use the strain gauges and will be attached will be attached near the fixed end of the region of the stunt pad, because if you can see the top figure, you can see at the right is the right, the region is the red is what we call it, we call is a critical part. That's why we attach the strain gauges near the fixed end. Okay, that's it from me. Uh, that's only from me for my presentation. Thank you.